In this video, we'll use Python comprehensions to solve the traveling salesman problem. For those who didn't watch my previous video, it was a review of comprehensions, and this video is an exercise using them. The traveling salesman problem goes something like this. Pretend there's a sales agent that lives in some home city, and from that city, it has to visit every city in a set of cities, and then go back home. The question is, in which order should the agent visit the cities in order to minimize the distance traveled, given that it knows how far each city is from each other city? Of course, there is a dumb way to do this, which is just to try every permutation of cities and choose the one that has the shortest sum of travel distances. But that's a lot of things to try. And by a lot, I mean if there are n cities, you'll have to try n factorial permutations, and that's really bad. So we have to be smart and avoid doing unnecessary work. Well, a crucial observation is that if there is a shortest path that visits a set of cities, then any subpath is also the shortest way to visit whatever it visits. So for example, if there is a shortest path that visits cities A, B, C, D, and E, and that path happens to go from A to B to C to D to E, then any subpath in this path, like A to B to C, or B to C, or B to C to D, all of those are the shortest paths to visit the cities that it visits. We can take advantage of that to solve the traveling salesman problem in a much more efficient way. And also, I should say that I 99% do not expect you to do this on your own. This is normally something you'd do in like your 4th or 5th programming course, and not right after you take CS 106A. So I'm just gonna be showing you an implementation, and you can just notice how I'm using comprehensions. The point is to show you comprehensions in action, not to teach you algorithms. So let's start off by looking at a problem instance. So here I have some test files. The first line is the number of cities in this instance. And then the next few lines, depending on the number of cities, is how far each city is from each other city. So here is how far the first city is from the first city, which is 0. And this is how far the first city is from the second city to the third city, to the fourth city, etc. And this is how far the third city is from the second city. And in this case, it's symmetric, but it doesn't have to be. And the implementation that I will use doesn't depend on it being symmetric. So we can have it more expensive going one way than the other. So here is the starter code. Here I have a test file constant, and here's the main function that reads the test file, prints the minimum distance that must be traveled to visit each city, and also print how long it took. So the part that we have to implement is this TSP distance function, which is right here. Use dynamic programming, you don't have to know what that is, to return the minimum distance required to travel to each city once and go back to a start city. Here's the hint that I was pointing to before. So let's implement it. So with that piece of information in the hint, I can get to the shortest path and therefore the minimum distance by building a sort of memo, starting with the information I have in the distance matrix. First, it would be convenient to have the number of cities handy, which is in the first line of the test file, and we have to convert it to an int. Next, I'll put the next lines in that test file in a distance matrix, which I'll make as a list of lists. So distance matrix is a list of lists. I want to convert each of these things into integers, and I see that they're separated by spaces. So int x for x in line dot split for line in lines, the second line onwards. Then start building a dictionary of the minimum distance to visit a subset of cities ending on a particular city. At first, I just know the cost to visit two cities, the home city and some other city ending on the other city, which is given in a distance matrix. I'll make the keys in this dictionary, this memo, tuples of subset and wherever I end on. So cost is the subset I want to encode as an integer. So it would be like in binary, if I want an integer to represent just a subset of just the first city, it would just be 1. If it's a set of just the second city, it would be 1, 0. If it's a set of the first and the second city, it'd be 1, 1, etc. So I can do that by saying here's a subset of just the destination ending on the destination maps to however far it is from home to the destination for destination in range the other cities besides home. So then, to fill in the rest of the dictionary, I have to consider bigger and bigger subsets of the cities using what's already in the dictionary to help me do that. That's the dynamic programming part of this. Let's see, for each subset size, I need to put in the dictionary the minimum cost to go from home to those ending on each one, but only visiting each city once. So for subset size in range, we're going from 2 now to the number of cities. I need to consider each subset of that size. So for subset in, to get each subset, I can use the combinations function in itertools, which is a library. So for subset in itertools.combinations, and this combinations function works like this. You give it a collection and a number, and it will give you a list of subsets from that collection that are that have a number of elements in it, the number that you provided here. So in this case, this should be range 1 to the number of cities of size subset size. Now I'll represent that subset as an integer. So subset as int is the sum of all the things in that subset. 1 left shift x for x in subset. Oh, by the way, left shift means, for example, 1 left shift x means 2 to the x. 1 left shift destination means 2 to the destination. Okay. So that's as integer. Now, for each destination in the subset, I'm filling in the cost dictionary. Subset as int. Destination is the minimum of the cost to go visit a subset of the cities besides, and not the destination ending at some city for that city in the subset. So I'm going to say side quest plus however far it is from that city to the destination for side quest in subset, and only considering those that are not the destination, not equals destination. So now that I've filled in the cost dictionary, I'll return the minimum to visit all the cities and then go back home. So the minimum of the cost to go to all the cities, which is 1 left shift number of cities minus 2, stopping at whatever last stop is the shortest way to do it, plus the distance from that last stop back to home. For last stop in the range of the other cities. And then that's it. So let's try it out. Okay, I happened to put the correct answer in the file name. So here's our test file. It's supposed to be 2085 and we got 2085. So that is actually a pretty famous algorithm called the held-carp algorithm. Held-carp. And a lot of people have come up with that independently, but now you know what to look up if you want to look it up. So that is all I have. Have fun coding.